I'm really, very happy to present my work. I have been working on my corpus, multi-layer corpus, for more than 6 years. So a long time during which I learned a lot. And of course, I won't be able to go into the details of everything, but my hope is that I can at least highlight the main issues that I encountered, issues that I think it's extremely important to be aware of, whether you build a similar corpus or you use it, you query it, something that many researchers are really not aware of. This is just a slide with the content I will talk about today. So just for the sake of time, I won't read this, but I will touch on these points. And I will immediately start by trying to define what a multilayer corpus is. So a multilayer corpus is a corpus where we have different annotation layers, which are kept separate, but they are connected to each other in a direct way or in indirect way. So as you can see, this image shows an upside down tree where the root is a text, what I call an original text. Then we can tokenize it. We usually tokenize it. We identify the units we want to attach some information to, and then once we have once we have a tokenization annotation layer, then we can use those tokens in order to attach, for example, morphological labels or syntactic labels to each of them. So this is why. So if you see the image, I think that it's pretty clear why some layers are directly attached to some layer, and others are just indirectly attached to other layers. But in general, what we get in the end is what we call a directed acyclic graph. This slide just mentions a few resources you should already be familiar with if you work with ancient Greek. So the Thesaurus, Lingue Graecae, Perseus Digital Library, and the Scaphe Viewer, which is the successor of the Perseus Digital Library. These are essentially, I would say, reading environments. They usually don't really allow for complex queries. The ones that, on the other hand, you should be able to perform, or at least more complex queries that you should be able to perform using OGA, so my corpus, Opera Graeca Adnotata, or Glaucs, the Glaucs corpus, which is probably the most similar resource to OGA. So it has been built using similar technologies. So I recommend you to check it online if you are interested. Getting to OGA. So OGA at the moment contains 1,999 texts and more than 40 million tokens. So as far as I know, is the biggest multi-layer corpus to date, and contains 7 annotation layers. I will talk about each of them briefly in the following slides. What I wanted to note here is that the data is available on Zenodo, and they can also be queried online using Annis 4. I wanted to note that when I started, I thought that I could just rely on GitHub, but then since the size of the data, since the data became bigger and bigger, it became very difficult / impossible to work on GitHub. So this is why I decided to upload everything on Zenodo. Of course, this is probably a point of discussion / contention. If you think that it is still useful to use GitHub also to track all changes that are made. But I would argue that probably for a large corpus, for a multi-layer corpus, probably you don't really need it, you don't really want it, even if I still use GitHub for documentation. So this image summarizes the phases through which I get my annotations done. The point here is that I rely on texts that are curated by other people. This is important because, as you can imagine, I regularly find lots of mistakes in those texts, but I don't try to correct them. I mean, I can open a GitHub issue, but I don't try to correct them within my release, within the release of my corpus, because the idea is that I simply rely on someone else's work. And when new texts, when corrected texts, new releases of the original texts are available, I can rerun my pipeline. Okay, so that's a design. This is the design for my corpus, and I think that this is a kind of a design that essentially allows me to take advantage of new releases of texts curated by other people, curated in other repositories. Just a few words about the standoff format, which is the underlying technology for Olga. So I start with what I call a base text. So this is the text that I take from someone else's repository. And then the first thing I do is to tokenize the text. So what is important to understand here is that tokenization is already an annotation layer, because we have to identify some units, and as you can imagine, there are different kinds of units. So usually we start with morphosyntactic tokens, but someone might be interested, for example, in prosodic tokens, which are different from the morphosyntactic ones. In this example, in the image, I show the three tokens, Hre, Dinoscane, and Hoti. So if we focus on Hre, so the tokenization level here in the middle of the image shows two numbers. So the first 5 is the offset of the token. So that means essentially that the token starts at offset number 5, and 3 means the length of the token. Okay, so this is a way to identify tokens in an unambiguous way. So you can imagine this repeated for each unit, for each token, and this is how I get my tokenization annotation layer. Another point here to note is that each token is identified via an ID, which then can be used in another annotation layer to attach for example, a morphological label. So for example, here, the token Gre, which has the T_3 ID, can then be annotated with this string NS and so on, which is a morphological label, because I essentially can use the ID in the morphological layer. So essentially, I refer to it and I say, okay, so the morphological label for the token T_3 is this one. And by the way, this probably is wrong, the morphological annotation, because this is done automatically, and the parser saw identified Gre as a noun, but it's a verb. What are the pros of this format? It's scalable, it's reusable, and the annotation layers are reusable, and we have no overlapping markup issues, because essentially we can identify different units, also overlapping ones. And in my case, the advantage is that using this format, Paula XML, which is a standoff format, I essentially could then use the Annis search tool, which is a query tool that is able to ingest data in the Paula XML format. This is also something to be aware of, because again, my goal was to allow people to use my data, all kinds of people, or also people not tech savvy people, so to speak. So having a search tool that can be used by anyone without looking at the XML file or at any kind of code was for me important. What is one con? Probably you might find a few others, but the biggest one, in my opinion, is that the data becomes the size of the data becomes bigger and bigger as we add new annotation layers, and frankly, the way I deal with this data, even from the programming standpoint, changes completely. So I have to use parallel programming, for example, because I have too many annotation layers, too many texts, and I cannot process all of them in a serial, in a sequential way, because otherwise it takes too much time. So what about the repositories I used? Again, this is just a descriptive slide. Probably you already know the first two repositories. The third one is a more recent one. And what is interesting here is that these three repositories belong to different projects, but I was able to use all of them, the data of all of these repositories, because they follow the same standards, essentially, which in this case is each text is encoded as a TEI epidoc text, and they also have an annotation concerning what we call the CTS structure. That is, each text is specified for its canonical divisions. So if we have books, sections, lines, whatever. So this is some piece of information that we find encoded in each text. So which means that someone some human encoded this information, and I could then extract it automatically, as I will show in a few minutes. What about tokenization? So I said tokenization is already a kind of annotation. In my case, it is rule-based. Why it is rule-based? Well, I first have to say that I started to work on this many years ago, and my goal was to find a way to extract the text from the TEI epidoc texts, because the issue, as you can imagine, is how can we distinguish let's say, what I call the real text, the text of a work, from what I call here paratext. That is all kind of metadata concerning some word or a few words in a text, but data that we do not really consider part of the text. For example, in this example here, I'm showing the content of a note. Okay, so I decided not to annotate the content of a note, and therefore I need of course, an algorithm being able to distinguish between the content of the P element from what is included in the note element. Another example is the choice element. So in this case, you see the choice element is about a correction of a word which is considered wrong in the original text, and therefore the choice element provides the correction, or at least the who edited the text decided that here we need a correction. But at the same time, there is also another kind of a choice element where an abbreviation is just expanded. And again, from my perspective, when I try to extract the text, I deal with all of these issues. And I can tell you there are many kinds of issues where essentially I need to kind of know exactly how the text was encoded so that I can identify the right pieces of text that I want to be included in my in what I call my text, the text that I am gonna annotate using machine learning. Another issue when it comes to tokenization about ancient Greek are crisis words. I actually have a list. So I worked on this separately, and then I came up with a list of crisis words and their resolution, so that essentially I can rely on that list in order to correctly split these words. But again, this is a kind of a philological issue that you encounter if you want to morphosyntactically annotate your text. I have tried to calculate the error rate, so how accurate is my tokenization. So on a test set of about 38,000 tokens, I found a very low error rate. Of course, let me immediately say, so this 38,000 tokens were randomly chosen from my 40 plus million token corpus. So it's just a tiny fraction. But again, here I just wanted to evaluate again how accurate I could consider my tokenization, and this is the error rate that I found. Let me also say that the errors that I found were mostly due to errors in the original text. So this is a case of error propagation, so to speak. So as I said, I don't try to correct the errors that I find in the original text. I try to open GitHub issues about them, but I wait for the next release of the text in order to get the correction done. I don't try to correct them in my corpus, because again, the idea is to rely on someone else's work. But of course, a con of this is that if we find mistakes, and we do in the original text, then those mistakes are likely to end up also in some annotation layer. For example, one common kind of error, excuse me. One kind of error that I found is that sometimes a footnote, the content of a footnote is not encoded as a footnote, so but as a main text. So at that point, if I don't, if my algorithm don't see a note element, it treats anything as text. Right. So, and this is why I get then mistakes in my annotation layers. What about sentence segmentation? Again, so here I have again a rule-based algorithm. Sentence segmentation is arguably easier, but again, there are issues because, for example, as I said, if a footnote in the original text is not encoded correctly, then you usually have in footnotes.
Okay, I think Giuseppe, you're frozen at the moment. Let's wait for the connection to.
Can you hear me, Andrea?
Okay, yeah, now you're back. Yeah.
Okay. So I was saying for the sentence segmentation, the main issue is that if, as I said, for example, we have some footnote in an original text which has not been encoded correctly, then it might be that I find in my text a lot of unexpected abbreviations where we have lots of meaning just abbreviations, but my algorithm probably will treat them as full stops for as the endpoint of a sentence. So this is why, again, we have a few, we have an error rate, which I think it's not that huge, but again, the test set that I used contains just 2,000 sentences. And yeah, let me also underline this, even if I think this should be by now clear. A huge issue is how can we evaluate our work? How can I evaluate my work when I deal with such with gigantic data? So this is I need somehow I want to evaluate that data because evaluation is a key point, is a key distinction between what we can consider scientific and what we cannot really consider scientific. We can find many things online, many corpora, and probably one major distinction is that what we consider scientific / academic is what we try to evaluate somehow, even if, again, I repeat that there are many issues in this respect and many limitations. So let's say something about ellipsis now. So why do I have to talk about ellipsis? Unfortunately, I would say, because this is a complex topic. So since I annotated my data automatically using models trained on tree bank data, and that tree bank data contains elliptical nodes. So the point here is that when I use this model at inference time, it expects data potentially containing elliptical nodes. Right, because the idea is that I should use a model on data that are similar to the ones that I used for training. But the original text that I have don't really have elliptical nodes annotated. It's just text. And let me also say, of course, I don't go into the details of how we can deal with ellipses when we annotate syntax for languages and especially for ancient languages. But let me say that when we started annotating ancient Greek, like, I don't know, more than 10 years ago, we had in mind a different design for our corpus. The world was very different at that time. And so we essentially didn't think that we could use that data as training data. We didn't really think of this, and therefore we just thought, okay, we can simply add an elliptical node when we think there is one for some reason, when the annotator thinks that we need an elliptical node. However, unfortunately, this this raises a lot of issues when we try to use that data for machine learning. And so the solution I came up with was just to train a model to identify elliptical nodes in the original text. So essentially, I have sentences, and then I have a model being able to tell me if a sentence contains no elliptical node or one or more elliptical nodes. So luckily for me, most sentences in the tree bank data do not contain an elliptical node. And as you can see from this image, so if we sum together the sentences with no elliptical node and with one elliptical node, essentially we get almost 95% of all sentences. Okay, so which essentially means that sentences with more than one elliptical node are very rare. Again, here I just I will go over this quickly. These are confusion matrices. If we focuses on the feed forward confusion matrix one, so the only thing that I want to say here is that so we find on the diagonal the recall scores, which essentially means that the model is very good at identifying sentences with no elliptical node, and kinda good at identifying sentences having just one elliptical node. But if a sentence has more than one elliptical node, well, then the model is not really performing well. This is again the solution I came up with in order to be able to identify elliptical nodes before I used my morphosyntactic models to add morphosyntactic annotations to the texts. Just again, a slide showing the texts that I used as a training data. I just wanted to note here that the tree bank data is diverse in genre and also composition date, which is good. And I would also underline the fact that the tree bank data now contains more than 1 million tokens, which is a lot of tokens. So it's a huge tree bank, I would say, if compared to many others, also many other tree banks for modern languages. So as I said earlier, I trained a parser in order to get automatic annotations. I use Truncate. Again, I don't go into the details of what morphosynthetic annotation is. I don't really have time, but let me say one thing. My final model that I call Truncate Plus has been annotated on much more data than previous models. So even if the metrics that you can see here are kind of similar, the major point here is that since my training data was much more diverse, I expect it to generalize better on my entire corpus. The truncate on UD model and the combo on AGDT model were essentially trained only on classical text. Okay, so this is why I think that the truncate plus model is better. Okay, not only because sometimes the scores are higher, but just because the training material was more diverse. So this is important because this explains why just looking at the numbers doesn't give you the full picture. Okay. Again, what about the CTS structure annotation layer I mentioned before? So as I said, this is just annotation enabling me to retrieve the canonical structure of a text if we find books, lines, whatever. And I was able to automatically extract this information because each text contains this information encoded. And this is why, as I said, I also limited my work to the text contained in the repositories that I showed you earlier. What about the work date annotation layer? So while working on this data, I understood that being able to query when a work was composed is, in my opinion, crucial, is fundamental. We should do that. And this is why, even if this was not really part of my original project, I decided to spend some time to add some annotation concerning the alleged composition date for each work. As you can imagine, this is extremely complex. We know sometimes we don't even know when a work was composed, but the goal here was, as I said, have at least an idea, some information about this. And since everything has been documented, so this annotation can be corrected, okay, can be reused, can be corrected, and I honestly think that it is useful in general. But let me also say that a problem that I had was the Annis search tool, which is this search tool that, as I said, I wanted to use, essentially, it's not able to understand the data type, the date data type, or not even integers. So this is a limitation of Annis. Therefore, I was kind of forced to find a solution, a provisional solution to make the work date annotation queryable somehow. And the solution I came up with was to encode it as a string. For example, if we have Euripides Cyclops, which we might think was composed between 411 and 405. So this is the year, this is the month. Of course, the month is, I always use January and December. This is the default choice unless we know, we have more information about this. But the point here, I had to convert this into a string, and I came up with this solution to use a label like M5_2, meaning second half of the 5th century. M stands for minus because this is before Common Era. So again, this is just to show this is one solution, and it was kind of dictated by a limitation of the ANNIS search tool. So it was not really due to me in a sense. But again, since I have I have a design for my corpus, and I wanted to use a few resources which are available. Sometimes those resources have an impact on how I encode my data, and this is one clear example.
Giuseppe, just sorry to interrupt you. Maybe you have like 3 to 5 minutes, so we then open the floor to questions. Yes.
Yeah, I also so I can just say I also added an APA transcription layer, so you can also query it. I don't say much about this. I just wanted to show you very quickly, and I hope I can quickly also share. Yes. Okay, so you find the documentation for this corpus online on GitHub. This also took a long time. And yeah, I cannot stress this enough because this is usually something that people don't really highlight as we should, because oftentimes people just are waiting for some accuracy score, F1 score, but the reality is writing documentation, the proper documentation takes a long time, and in my opinion is fundamental because this is actually what allows you to reuse my data. For example, if you wanted to query the data, again, you find a bunch of files. For example, I mentioned before the problem about the dates. Okay, so you find everything here. So you find each work that you find in the corpus, and you find the values that you can expect, that you can query. So again, I don't really have time now, but I also show you a few examples, query examples, because yes, let me say, in order to use ANNIS, you have to know how to use, you need to know a little bit of the ANNIS query language. It's not that complex, but of course, it takes some time. I provide some explanation. And yeah, so this is an example of what if we wanted to query the corpus for all the verbs in the third books of the Iliad by Homer. Okay, so this is the query. Of course, if you read it, maybe you can get the point. It's much more difficult if you don't have examples. But let's say, now my point was just to show you that you can actually use all the fields, all the annotation layers I talked about to actually query the corpus here in ANNIS. Or of course, if you can code, you can also use directly the data on available on Zenodo. Okay, so I would say, so since it's really I have talked too much for a long time. You can I would end here. I just can show the last. Wait a second. The last. I just show you the slides with, let me also say, I hope for collaboration. The idea is that the data should be reused, and I would like to get help from anyone if mistakes are found, and they are there for sure, because the corpus, as I said, is really big. There is much information there, and yeah. So thank you for your attention, and I'm happy to get questions from you.
Thank you so much, Giuseppe. That was really fascinating. So I think there was already a question in the chat. So for people in general, I mean, if you have any questions, you can just raise your hand and speak, or write them in the chat. But I think there was a question by Charlotte already. Hi, Charlotte, by the way. I think because I don't know, like, because it's I mean, she wrote it like about 20 minutes ago, 25 minutes ago. It says, is CTS is still useful? What about DTS? And then there's a link. I think it was a question for you, maybe where you were talking at the beginning.
Okay, so I've not looked into this distributed text services, so I cannot really answer your question. I what I can tell you, however, is that CTS, as I said, is encoded in the original text. So I know that this is some protocol, some standard that is there, and therefore, yes, I think it's useful. But as I said, unfortunately, I don't know this distributed text services, so I cannot really answer your question. But I would argue that probably this is based on CTS. I don't know, maybe.
It is. It's the same team. It's the same team. I think they're going to absorb CTS, but
Okay.
it's a very, very new, but it may end up as an improvement, particularly for later texts, which are not always very well described.
So thank you, because this is a way to learn. So I'm very happy because now I will read the documentation. What I can tell you from my perspective is, since, as I said, I take the original text as they are, the problem is, are they gonna annotate somehow? Are they gonna put this information in the original text so that yes, great.
Yeah.
So, well, in that case, then I will have to update my algorithm. Probably I won't have to change it dramatically, but yes, in this case, I will adapt my algorithm to this new technology. Yeah, that's the point. Yeah,
Cool.
relying
Thank you.
on.
Thanks.
Thank you. Do we have any other questions from the audience? So maybe while people think about it, I saw on the Annis portal. Oh, sorry. Well, later there is a question from Romain. Yes, please.
Yeah, thank you very much for the presentation and for your work, because it's an amazing work and essential. I want to ask about the API. Is there an API that we can use to query easily without having to add all the text into our own database? Or
No, there is no. I think that for API, probably you think a system where maybe you can easily query using Python words or passages. No, I don't have this in place, because, as you can imagine, this would be a lot of work, much computational work. And the problem that I had, thank you for this question, because this gives me the opportunity to stress this again, is that so I can just tell you that I was lucky that I had funding in order to buy a new server where I actually can process all my data. Because even the instance of Anis that is available online requires many resources, and it is on a dedicated server. So this is just to say, having an API for the entire corpus is something desirable. I would like to have it, but at the moment I don't have the resources for this. So I would say probably in the future, if I can still get funding, yeah, I would like to get an API. But for the moment, you can just download the data on Zenodo essentially, and you can also use Anis on your computer. It's not that complex, but yes, the problem is you still have to download all the data. So this is why I wanted to have an instance online. So yeah, this is a limitation.
I'm sure if you do a ERC project for this kind of stuff, it will be fun. It's for sure.
Well, I would hope. Thank you, but I
No,
don't know. Well, thank you for the
I
optimism.
really
Sometimes
believe it. Yeah.
I'm so pessimistic, but thank you. It's made my day. Seriously.
Thank you. Do you have any other questions? So mine was just more of a curiosity, and then I also have like an actual question. So the curiosity was like when you show the Annis website, I saw there was like the phonetic transliteration of like all the words. Is it something you
No, so the data I used were the ones that you find on Wiktionary, essentially.
Okay.
Yeah, so it's a kind of an experimental annotation layer, but I think is very important if you study poetry, but also prose. So the interesting thing is that I've been the guy who created this data, but the actual potential of this data is still uncovered because, for example, people could use the API transcription to see how to study prose rhythm, for example, which is a huge topic. And yeah, so let's say there is much that can be done, and but the data, the transcriptions come from Wiktionary. So I also had to extract them. It was not also easy, but anyway, I did that, and these data are also available online, so they can also be reused.
Okay, thank you. And then I also have another question, but let's wait for, I mean, I want to see if there's something else from someone else in the audience, maybe. So well, the question is, I don't want to open like Pandora's box, but is this like, does it pave the way, let's say, to implement your annotations with semantics somehow?
It can be done. It can be done. It's again a problem of tokenization, but once you have the proper tokens, you can attach any kind of annotation. That's the point. So you can take the entire corpus and then add just your semantic annotation. Of course, you have to agree, I would say, with the tokenization notation layer, but you could also provide your own tokenization layer. Again, yes, anything, well, much can be done in terms of adding annotations. So also semantic annotations. I have so far I have been working on, let's say, creating the infrastructure, the underlying technology. So this standoff annotation and giving also examples, but and also, yeah, I mean, programming in terms of making an Annis search tool instance available. So this was a lot of work, much more than I thought at the beginning. But yeah, you can potentially add any kind of annotation.
Thank you. Yes, Romain?
Sorry, yes, just to say, I did it. So yes, it's it's not so difficult. So you
Okay,
need
great.
a SQL database. You can or quadrant vector database. You can just add the vector and link it to the passages and query with natural language, and it's good.
Yeah, of course. There are many options. I mean, the Annis search tool is essentially designed for probably linguists. I mean, people who don't really program, and it's a kind of interface for them. But of course, there are many kinds of API that we can think of, and yeah, this is an open question for me.
Thank you. Any final questions? Any final thoughts about these? Well, if not, then we can thank again our speaker, Giuseppe, for introducing his amazing, I would say, corpus. And thank you all. I'm thanking all the participants as well. We have more seminars coming. So in the chat, I pasted the link to our Computational Humanities Research Group. So if you want to check what's going on, there's the link. And thank you again to Giuseppe and to all the the attendees. And we'll see you next time.
Thank you to all of you.
Thank
Bye-bye.
you. Grazie mille. Ciao, ciao.
Ciao, ciao.